Thank you PCBWay for sponsoring this project video.
Alright guys, so welcome back. So, the great folks, the very generous folks over at PCBWay decided to sponsor another project video of mine. And I did a whole bunch of recording about this already and didn't have the mic turned on. So I got to do it all over again. Anyway, thank you PCBWay for sponsoring this project video. They even sent me a nice Christmas card. Even sealed with some wax, man. Thank you guys. Like I said, I already started this. So basically what I started to do when I got this thing, it was so this is stainless steel. The first project I did with them was having them print out an aluminum disc with just 4 holes in it. I decided I wanted to try some of their other alloys, maybe even going through all their alloys. So this is stainless steel, much heavier obviously than aluminum. This weighs the same as this with the magnets on it. And it was a dark gray, and this is non-magnetic, so it must be like a 304 or something close to it, because it's not even slightly magnetic, which is even better. But anyway, this was a light gray, the same way as the other one was, probably the same way as they all are, because it's all done with a metallic powder and then lasers, another layer, laser, another layer. It's almost like SLA but upside down. And I wanted to see if I could get it shiny like that. I don't know if you guys can make that out. Yeah, you guys can make this. See how shiny that is? That's from me rubbing it on 1500 grit sandpaper. You can even see it better over here. What I'm trying to do is get it so the ends came out really nice. They came out really nice. And of course the tolerances, I just measured it. This hole's supposed to be 22.2. It's 22.1. This is the same thing over here. So the tolerances are almost the same, maybe even a little bit better than FDM printing. I can dial my FDM in pretty well, though. This is for skateboard bearings. So, but what I want to try to do is get it all to look like this, nice and shiny, and I'm not really sure how to do it. I'm going to try some wet sanding and see what that does, but I think I have to knock down these high spots first. Like these high spots here are the ones that are shiny, and this table here is a piece of I don't know if it's marble, but it's pretty flat. It's probably one of that faux marble stuff, whatever it's called. But yeah, I've got some 400 grit, which is a little aggressive. I'll probably go back to the 1500, or maybe even go to the store and see if I can get some 800,000 and then work my way up to 1500. But what I want to do is I really want to get it shiny. I don't want to get too aggressive with it using a sanding disc or anything. I can maybe try that on this side, because this is the rough side. It's weird because I have no idea what it looks like when it comes straight out from the printer. I think it has to be baked, but I'm not 100% sure. But this side is much rougher than this side. So one of these is the top and one is the bottom. I'm going to guess this is the bottom, which is actually the top. Yeah, so what I want to do is I want to try to get it nice and shiny. And again, I've got 8 slots. I've got to tap these holes. And I've got 8, I've got 8 magnets kind of like this, a little bit smaller magnets. I think they're like 5/8. Anyway, stay tuned, guys. All right, so I've been shining it up, and it's coming out pretty good. But I can't seem to get a uniform shine. I would have to take way too much off. But it's not bad. It's definitely stainless steel, that's for sure. Nice, shiny. Like right there is really nice, and then it's a little. So these are high spots here, And on this side here, there's a couple of high spots. That's pretty uniform there. All right. That's probably what I'm going to do with it. Now I'll try to tap these holes. In stainless steel, it's going to be a little tricky. I've never had luck dealing with stainless steel, but this is 3D printed stainless steel. So thank you, PCBWay. All right, guys, stay tuned. All right, so I got it tapped. I kept hearing that ting, ting, ting as I was tapping, especially when I was getting towards the end because I was getting tired. And I was saying, oh man, please don't break. Because every time you hear that ting sound, it's usually a tap breaking. But these are all tapped 832. The holes are, I believe the holes are 4 millimeter, and that takes an 832 tap pretty well. But I got them all tapped without breaking any taps. Yay! Did hear a lot of tings though. So I'm going to do something different with this one. I want to set it up using reed switch. I haven't used a reed switch as a circuit in a long time. I mean, I'm still going to use my regular circuits, but I want to try a reed switch with this. All right, stay tuned. All right, this time I remembered to turn on the microphone first, so here it is. I still have to put the bearings in. I still have to print out the top there. I needed to put a nut for a spacer because even though I did tap it all the way down there, the bolts I had were a little bit too long, alternating north south north south. Still going to try the reed switch, but first I'm going to do one of my old faithfuls, the JL94 circuit. Get this puppy flying because these are screwed in nice and tight. They're not going to come flying out at me like the like the Christmas ornament rotor. So yeah, let's get this part printed out, get those bearings pressed in. Again, thank you PCBWay for sponsoring this project video. Couldn't have done it without you guys. Been very gracious, helping me along on my journey here. Yeah, so this is the second one. This is stainless steel. The first one I did was aluminum. I don't think I can afford titanium. Now there's a box when you go to PCBWay. There's a box there. It talks about all the different metals you can do. Then there's a box that just put any metal you want in there, and they'll see if they can do it. So I may try to see if they can do copper. That would be interesting. I can't imagine it's that much harder than stainless steel. Anyway, stay tuned. Okay, so here it is. It came out pretty good. Nice and shiny. North, south, north, south, north, south. Really heavy. I'm going to probably do this on my probably do it on my mid-size stand. Yeah, I really like this stuff. The ability to do 3D printing with metal is amazing. There's no way I could do this with a hunk of stainless steel. So again, thank you PCBWay. Guys rock. Yeah. So let me get it set up in the stand and get it going. All right? Stay tuned. All right, so it has a really nice spin duration. Those bearings are really nice. Spin it by hand, it'll go forever. As you can see, little spin zen thing going on. All right, let me get things hooked up and then I'll bring you guys back. All right, so I've got it hooked up to just one of the sides of the JL94. I was having a hard time because In order to get this circuit to run, you have to get it going pretty fast. And it also depends on the size of the coil. But it's flying now. And I'm getting some decent output over here. But I want to get it hooked up to both of them. And I also want to run it off of this super cap bank I have here. But she's running okay now. Decent clip. Again, getting solid output, not blinking for me. I don't know if it's blinking for you guys. No, it's not. It's pretty solid. Yeah, that is pretty solid. So much so that the neon's even lighting up a little bit. So I'm getting too much back EMF. But it runs really smooth. Really true, too. Let's see if I can get this thing in here a little bit. Yeah, it's running really nice and level. No way those magnets are flying off. As he says, famous last words. Alright, let me see if I can get this thing hooked up properly. Stay tuned. So that's one of Sky's coils. It's a really nice coil. It has a pickup side over here. That coil had no problem. So, come to realize that with this size rotor, with those size magnets, I need bigger wire in my coils. These coils that I've been using are too small. This pickup coil's got 20 gauge wire on it. And it fired up no problem, really fast. I gotta see what the pickup side says. Let's see if I can do it right here like that. Oops. Let's see what I can get. Yeah, I'm getting 10 volts AC on the pickup side. You guys can't see that. 9, yeah. 10 volts on the pickup side. That's pretty cool. I just wanted to show you that one coil. It's a monster. It works really nice. Anyway, let's keep this thing going. Put some different circuits, different coils on here. Stay tuned. So here's another Sky coil. This is that curved one. This thing works really good. And again, I'm just doing one side, getting that solid output. I can even switch it over to this side. Funny because it doesn't work this way very well anyway, but it works really good this way. I don't dare let it go. I know it'll fall right into the... Yeah, if I keep it like this, it'll start to speed up. Yeah, it definitely likes more and bigger wire. Interesting. Alright, stay tuned. So I can get it going with the thinner wire coil. Whoops. Go down there, buddy. This one's really flying. I only have one side of the JL94 dual circuit hooked up. Oh, this one's really flying. Yeah, let me turn it off. Stay tuned. Alright, I got it going now with the two halves of the circuit. As you can see, it's really screaming now. I got to figure out a way to mount these coils. I'm getting solid output on both sides, so much so that both the neons are glowing too. I really got to set this up so that I could take my hands away. This is a really bad idea. That little puppy is screaming. All right, let me take it out. Turn this off. Yeah, I really need to set it up so that it doesn't, set it up right. I'm so impatient to get it going with the dual circuits. Now that I know it works fine, I want to run it off of the super cap bank. So stay tuned. Alright, so I have it running off of the super cap. Running really well too. I charge the super cap up to 16 volts. Each of these are 2.7 and I've got 6 of them. 2, 4, 6, 8, 10. Yeah, like 16 volts you can put it up to. And it's going pretty good. I don't know how long it'll run for, but I'm getting really good output. Let me see if I could. Yeah, I'm getting really good output. I'm running for quite a while. Let me take a reading and see where I'm down to. I'm only down to 13 volts. So it should run for quite a while. It's nice, huh? Stainless steel rotor from PCBWay. Thank you guys. All right, everyone. Ciao.